This is the project we'll be building in today's video. It is an Arduino smart lock system and it's currently connected to my laptop, and very few components basically. We have the 16x2 LCD, we have the keypad, and we have the servo motor. Obviously an Arduino, and yeah, right now it is locked. So we've entered the password, which is right here, 9867BCD. It opens, door open, welcome, and it locks by itself. And now we have to enter the password again. If I enter the wrong password, which is 89671234, wrong password, nothing happens. I'm prompted to enter the password again, which is 9867. You get it, 676. Anyways, B C D. Door open, welcome. Servo motor is open, and it locks itself again. So I'm going to take you through the connections for this particular project. And yeah, very simple setup. Mostly it's the connection and the code. Obviously, I'll share it if you guys are interested in that. But the connection is also as important. And let's get into it. I will start taking you through the components and through the connections that this project is going to require you to use or require you to do. So here are the components: an Arduino, like I've already mentioned, 16x2 LCD, a 10K potentiometer, 4x4 matrix pad, servo motor, jumper wires, and a breadboard. Obviously, those are what you need. You don't need much. If you have a starter kit or anything of that nature, then you should be good to go. And here is the connection. So all the power and all the ground connections are connected to the same Arduino 5 volts and the Arduino ground. And if you notice in my connection, like in the physical implementation, the 5 volts and the ground are connected to each other because I use the jumper cable across. So I'm able to use both sides of the breadboard for the positive and negative, basically. So make sure your ground is connected to the Arduino's ground. Make them in a general place, and also the positive, the 5 volts is connected to all the 5 volts. And basically, all I'm trying to state here, your Arduino 5 volts is connected to your LCD VCC. And I'm going to go through this again. So 5 volts to your LCD has 16 pins. So VCC is one of them. So your LCD has VCC is connected to your Arduino 5 volts. You can it's better to use a jumper wire for this, because connecting it directly to the Arduino is going to become very messy. So Arduino 5 volts to your keypad VCC. Your keypad also has a VCC, but it probably doesn't have, if I'm being honest, but mine doesn't, but I've seen some that does. It's not really common anyways. So your Arduino 5 volts is connected to your potentiometer outer pin, and I've already gone through most of this anyways, but your 5 volts is connected to your potentiometer. So your potentiometer has 2 pins, which one is connected, so it has 3 pins. One is connected to the ground, one is connected to the 5 volts, and one is connected to to control the resistance of what you want to control. And the Arduino ground is connected to the LCD ground, like I've mentioned. Also, your servo motors as a ground, the servo we're going to be using. And the potentiometer also, like I said, that's a ground pin. It's connected to the ground. Basically, just connect your ground to the ground and your 5 volt to the 5 volts. That's basically what this is. And yeah, like I said, all grounds are common. All grounds. All grounds are common. Come on, man. Just trying to highlight stuff, you know what I'm saying? What else? Okay, we have the LCD connection here. And like I said, we have the 16 pins, LCD pins, and what they connect to. Basically, the VSS, that is the ground, connects to the Arduino ground, like I've mentioned. VCC connects to the Arduino 5 volts. V0 connects to the potentiometer middle pin. This is where you control the contrast of your LCD. And the RS connects to your Arduino A5, RW to your GND, E to A4, D to D2, your Arduino D2 basically, and D5 to D3. And these are the digital pins, by the way. D7 to D5, D6 to D4, of the LCD pins to the Arduino pins, just like connecting them properly. And yeah, you have the anode and cathode. The anode and cathode is basically like, um, positive and negative, and that's the 5 volts on the ground. This is just your backlight. Just control it, just like, you know, important, I guess. And what else do we have here? We have the potentiometer, obviously, like I've already said. We have three pins. We have three pins there. The 5 volts, the ground, and the contrast for the LCD. That's the VO. The middle wiper is connected to the LCD VO, like also here. So the shorter middle pin is connected to the VO. Something I forgot to mention is that maybe your LCD is labeled different. Your LCD system might, maybe you have something like VDD and VDD and something else. I don't know what it's called. Maybe your positive side is labeled VDD and maybe they are flipped. So you need to be careful of that. VDD and something else. I don't know what it is. Let me Google that real quick. Is it VDD and VSS? I think so. Oh, sorry. Yeah. I know like sometimes they'll call like the positive side VDD. Yeah. Sorry, my bad. And obviously the negative side is VSS. Yeah. So sometimes you see something like that. Just be careful of your labeling. If you're not sure, just Google it and you probably be on track. Again, just be careful with the connections. Just make sure you're connecting the right wires to each other, because this can either like cause errors or blow up your circuit or something like that. And yeah, just be very careful. Look at it properly. Just ensure it can be frustrating. It can be annoying, but that's what you signed up. That's what you signed up for, no? Um, I also struggle with it, so it's normal. And also your keypad, you have like eight pins or whatever. It's not really pins, but you can put a wire into them, and basically you have eight of them. So one, two, three, four. The first four is for the rows, and the second four is for the columns. So basically, connect the first one to D6, the second one to D7, the third pin to D8, and the fourth pin to D9. And this is to the Arduino board, obviously. So connect them properly, and then the next four, which is for the columns, connect the fourth one to D10, um, the fifth one to D11. How am I saying? Sorry, this is the sixth one, the seventh one, and the eighth one. Just connect them properly. You have eight pins. Connect them to D6 to D13, like respectively. D6, D7, D. It's not really. This is not really an add connection to this thing. And again, like I said, I made a mistake of like mismatching or flipping the connections. Like I was connecting the columns, I was connecting column 4, the last pin to, D6, and row 1 to D13. So again, ensure your connection is right. And I had to fix that. Obviously, it didn't take me time, but again, one of those things that happens. And your servo motor connections, again, did I mention? No, I didn't mention this. So your servo motor has 3 connections, obviously. You have the brown, black, and the yellow, which connects to your A0. So the brown obviously is connected to the ground, and the red wire connects to the 5 volt, which is the power basically. And the third and the yellow one, these wires are either brown or black, and the red wire is always the red wire, and the yellow or orange connects to your A0. That is for this project. It can be different for any other project. And the reason why I said you should follow all this connection is because the code that I am using to run this, if you're interested in this, let me know. I can just give it to you. The code I'm using to run this project requires you to have those pins in those places that I have listed in this in this connection, basically in this explanation. So connect it the way it is presented. If you want it to work the way or maybe you already have an idea of how to do something like this, and you don't have to. I can easily bend the rules and edit the code if you want. But the reason why is because the code actually uses the connections the way it is and requires the connections to be connected to those pins. And yeah, basically that's it. And the code, obviously, I don't understand it. I'm not gonna lie. It's not that I don't understand it, I understand it, but I cannot properly write it. I cannot properly explain it to you if I'm to explain it to you. You understand? But I can understand what it does. I can understand, like, obviously this is the lock position, this is the unlock position. I get it, but I can't actually say I wrote this by myself. This was AI generated, so, and I just said, generate code for this because this is something that would actually require time writing code for a microcontroller because because I know it's gonna take time. But basically, I didn't write this code. If you want to use it, feel free to message me or whatever, leave a comment, and yeah. So now I'm going to show you like the physical implementation of this, and hopefully you have been able to gather something from this video and be able to implement it yourself. If you have followed the wiring as I've described in the video, then you should have something that works like similar to mine here. So you basically connect it properly using a breadboard, or maybe you even solder it yourself. And if you enter the password, the servo motor obviously unlocks, and if it's the wrong password, nothing happens. So 9867 B, C, there we go. And it locks itself after like a few seconds, obviously. You can also like use an RFID for this and, kind of make it much more simple and using a RFID key reader. So that's it for this video. If you like it, enjoy. If you like it and enjoy the content, like and subscribe. It's fucking chaos out here, man. It's chaos, absolute chaos. How am I meant to connect all of these wires? Because this tiny thing, look at my hands, look at the size of my hands compared to, look at this. This is my hands right here. And I'm actually connecting jumper wires in very tiny holes, by the way. My hands are so big. I have to be connecting them in this tiny little hole right here. Yeah. And I have to connect all of these wires. I have to know which is which and connect them rightly to the keypad. Insane. Absolutely fucking insane. And I'm not even done. Stress, man. I finally got a relatively presentable version of this, which is going to be the final thing. As you can see, I've actually like stuck the LCD monitor onto the board and not like use jumper wires for it or DuPont wires. Yeah, so this is what I'm going to use finally. As you can see, it's midnight already compared to earlier. Anyways, this is what I will present for the video.